So good morning all. Today we will discuss an important concept called modulation and also the need for modulation. In our earlier lectures, we discussed what is a transmitter, receiver and channel, that is various blocks involved in a communication system. Today we will discuss an important concept called modulation. So as a part of this lecture, we will study three different important topics. One is modulation and the types of modulation and what is the need for modulation. In addition, we will also study how modulation is enabling a process called multiplexing. Okay. So modulation. So as we all know, modulation is the process of changing the characteristics of your carrier signal with respect to your message signal. Okay. You will change the characteristics of your carrier with respect to message signal. That is called modulation. Okay. So consider I'm speaking. Okay. So my voice signal will vary in the range of 20 Hertz to 20,000 Hertz or 20 Hertz to 20 kilohertz. The audible spectrum range will vary from 20 Hertz to 20 kilohertz. Okay. So my voice signal, whatever I'm speaking, is of low frequency. Clear? Okay. It is of low frequency range. So this low frequency signals, whatever I speak, audio signal, cannot travel over long distance. Okay. So because of this, I should make an arrangement to allow this low frequency signal to travel over long distance. For that alone, I go for modulation. So this process of allowing your low frequency message signal to travel over long distance is enabled by modulation. Okay. So you have your message signal, that is the voice signal, and you have another signal called carrier signal. Okay. So message signal and carrier signal are the two signals involved in any modulation process. Okay. So this message signal is of low frequency and carrier signal is of high frequency. So what I'm doing is, with help of a high frequency carrier, I'm superimposing this low frequency message signal. So the superimposing your high frequency carrier with the low frequency message signal will allow this low frequency signals to travel over long distance. Okay. So that is called modulation. So a similar kind of example is, consider a stone and a paper. Okay. A paper, when you throw a paper, it cannot travel over long distance. Whereas when you throw a stone, it can travel over long distance when compared to your paper. Okay. So your stone is of high weight. Okay. Your paper is of less weight. So when you wrap your less weight paper onto the stone and you are throwing it off, it will travel over a long distance. So the same process is employed in modulation also. Your low frequency carrier is superimposed to a your low frequency message signal is superimposed to a high frequency carrier, and because of this, it is traveling over long distance. Okay, so that is called modulation. So with help of definition, if I want to define modulation, modulation is the process of changing the properties of your carrier signal, okay, with respect to your message signal. Okay, you are changing your characteristics of your carrier with respect to your message signal. That is called modulation. And remember, your carrier is always of high frequency, your message is always of low frequency. Okay, and you all know, see, this is analog modulation or a continuous wave modulation. Okay, so you will have analog signal. So you know the standard equation for an signal. Let us take V of t. So V of t is a standard signal. So if I write a sinusoidal signal in terms of cos, I will have it as A cos 2 pi f into t. Okay. So it is a continuous wave modulation. So what properties you can change with respect to your carrier? So any signal will have three properties. Okay. So A is nothing but your amplitude. Okay. F is nothing but your frequency. And pi is nothing but your phase. So you can change three properties of your modulation amplitude, frequency, and phase. Okay, so if you are changing the amplitude of your carrier with respect to your message signal, it is called amplitude modulation. If you are changing your frequency EF of your carrier with respect to your message signal, it is called frequency modulation. If you are changing your phase phi with respect to your modulating signal or message signal, it is called phase modulation. So either you can change your amplitude, phase, or frequency. Okay, so depending upon the characteristics you change, you got 3 different modulations. So analog modulation is classified into amplitude modulation and angle modulation. So this frequency modulation and phase modulation are combinedly called as angle modulation. Okay, so there are 2 types of continuous wave modulation. One is called amplitude modulation, and the other one is called angle modulation. Angle modulation is further subdivided into frequency modulation and phase modulation. Okay, so that is what modulation is. So this is a diagram. So your voice signal is of low frequency. It is varying from 20 Hertz to 20,000 kilohertz. Or your voice signal, whatever you speak, is in the range of 3 kilohertz. Okay. So this message signal is called by different names. You can call it as information bearing signal or baseband signal, message signal, or modulating signal. So these are all different names of your input message signal. So message signal can be called by different names. So baseband signal, information bearing signal, message signal, and modulating signal. Okay. So when you transmit the signal with help of a high frequency carrier wave by either changing amplitude, frequency, or phase, it is called modulation. And remember, you will only change your characteristics of your carrier. Your message signal will remain as such. Okay. So this is your diagrammatic explanation of a modulation. Okay. And next one is need for modulation. Okay, so we have learned what modulation is, and your first property is what is the need for modulation. Why should we go for modulation? That is our important focus. What is the need? Why should I modulate? Okay, so one thing I have explained, first point, radiate low frequency signals. This I have explained already. I will reiterate it again. See, your audible spectrum range, that is the voice signal, whatever you speak is of low frequency. It cannot travel over long distance. So to radiate your low frequency signals, okay, you should go for modulation. Correct? My message signal, whatever I speak, that is my audio signal, is of low frequency range. So I want to transmit it over long distance. Okay, so I cannot transmit it directly without modulation. So only if I do modulation with help of a high frequency carrier, I can transmit my low frequency signals to a longer distance. So that is your first need for modulation. And next one is reduction in antenna height. Okay, so as you all know, this the relationship between lambda, you know, lambda is equal to C by F. So this is the relationship between your wavelength and your frequency of operation, F. So let me explain this reduction in antenna height with help of an example. So consider your frequency F is 10 kilohertz. Okay. Okay. And calculate your lambda. Okay. So 3 into 10 power 8 divided by 10 kilohertz, 10 into 10 power 3. So what is your lambda? So let me calculate this. 3 into 10 power 8 divided by 10. So it is approximately 30,000. Okay. Okay. And consider another thing, another range of F. So let me assume it as 1 megahertz. Okay. So 1 megahertz. So now I'm calculating my lambda. So lambda is equal to 3 into 10 power 8 divided by 1 into 10 power 6. Okay. So you will have it as 3 exponentially divided by 300. So here lambda is 300. So what is your observation here? At low frequencies, your antenna height is 30,000 meters or 330 kilometer. Correct or not? This is nothing but your lambda will require 30 kilometer, whereas in this case your antenna height is nothing but 300 meter. Okay, this is 30 kilometer and 300 meter. See, it is very difficult to install an antenna of height 30 kilometer. 30 kilometers is a very long antenna. You cannot create an antenna of that long size. Okay, but when you use modulation, your antenna height is reduced to 300 meter. See, what is this when you use modulation? So you all know when you use a modulation, your low frequency message. See, 10 kilohertz is in the audible spectrum range. Correct or not? Okay. So this is a low frequency message. So this, if you directly without modulation, if you're transmitting, your antenna height is what, 30 kilometer. But if I use a carrier is always of high frequency, you know. So I'm choosing my frequency. So my modulated carrier is around 1 megahertz. Okay. So if I choose a high frequency value for my carrier, if I transmit it, I could see there is a reduction in your antenna height. Okay. So this modulation, you all know, is just frequency conversion. Okay. You're just converting your low frequency to a high frequency. So when we use a high frequency, so when my modulation uses a high frequency, so this modulated carrier is 1 megahertz. So if that is the range, my antenna height is reduced drastically. Correct or not? 30 kilometer is very large. It's very difficult to install antennas of such a long height. Okay. So whereas 300 meter is very simple. You can easily install antenna of 300 meter size. Okay. So that is what. So this modulation, the essential important need is reduction in antenna height. So if you use modulation, definitely your antenna height will be reduced. I have explained this with help of a simple example. Okay. And next one is increases the range of communication. So the same thing, increases the range of communication is directly when you transmit your low frequency signal, it cannot travel over long distance. If you go for modulation, it will travel over long distance. So what is it traveling over long distance? That is nothing but range of communication. So your modulation will increase your range of communication. And another one is improves the quality of reception. Okay, so there are advanced modulation techniques. Okay, like digital modulation, and there are multiple techniques like OFDM, multi-carrier modulation. So these are all advanced topics in modulation. So when you go for those techniques, you can reduce your noise to a very small extent. Okay, so that is how it will improve the quality of reception. The quality of reception means whatever you're transmitting it, you'll be able to receive in your receiver. So that is called quality of reception. So whatever you're transmitting, with reduced noise or interference, you will be able to receive at your receiver. Okay, so that is called improving the quality of reception. So with help of advanced communication techniques like digital communication, multi-carrier communication, all your quality of reception is improved. That is your next point. And next one is multiplexing and reduction in noise and interference. So this I will explain with help of a schematic. Okay. So next important need for modulation is multiplexing and reduction. So multiplexing. So consider you have 5 different speakers. Okay, each are transmitting signal which is of very close range. Okay, 5 different. See, normally 5 speakers are speaking. Their frequency, message signal frequency is very close to each other. Okay, so if I transmit my unmodulated frequency, ultimately this is my transmitted part, this is my receiver part, and the signal is transmitting via a channel. Okay, in my receiver part, if all my message frequencies are transmitted without modulation, I will not be able to receive anything. Correct or not? Because the frequencies are very close to each other. Okay, and ultimately there's nothing but noise or interference. I cannot receive anything if I go without modulation. Whereas if I perform modulation, so this low frequency message signal is modulated with different carriers. So F1 will have different carrier, F2 will have different carrier, and so on. So this low frequency signals, message signals, are modulated with help of a high frequency carrier, and each carrier is different, and the frequency spacing is such that the carriers does not interfere with each other. They are spaced well apart. Okay, so there is no interference when you go for modulation because of this high frequency carrier. The frequency spacing is selected such that there is no interference between adjacent speakers. Okay, so when you perform this modulation process and you are transmitting it via your channel, since each speaker is separated by different carrier frequency, you will be able to receive your speaking information at your receiver. Okay, and after receiving your information, if you go for demodulation, you can extract your original message signal. So that is how multiplexing is happening. Okay, that is within the same channel with different carrier frequencies, you are transmitting different message. Okay, so with different frequency locations, you are transmitting different message in a common channel. Okay, this kind of multiplexing is called frequency division multiplexing. That is, your carrier frequency is different frequency. Okay, so carrier is having different carrier frequencies. Because of this different carrier frequencies, you are transmitting your message which is close to each other. Okay, so because of this, you are able to transmit different message signals simultaneously over a common channel. The channel is shared. Simultaneously, you are transmitting different message information with help of a different carrier simultaneously. So this process is called frequency division multiplexing. Okay, when you go for this frequency division multiplexing, you are able to receive your signal at your receiver, and after receiving a signal, you will perform demodulation and you will extract your original message signal. So there is no interference or noise. So whatever F1 I'm transmitting F1, I'll be able to receive F1, okay, and F2, F3, F4, and F5. There is no noise or interference when I go for modulation. But without modulation, if I'm transmitting, because since all your message signal are very close to each other, ultimately in my receiver I will receive a kind of interference. So channel 1 will interfere with channel 2 and so on. Okay, that is the reason we go for multiplexing. So multiplexing is having dual benefit. One is it is trying to transmit all signals simultaneously over a common channel, and other one is it is reducing your noise and interference. So only if we go for modulation, we will be able to achieve both these benefits, multiplexing as well as reduction in noise and interference. Okay, so as of now, we have discussed what is modulation, what is the need for modulation with help of some examples. Okay, so the key takeaway from this presentation is you understood what is modulation. And what is modulation? Modulation is transmitting your message signal with help of a high frequency carrier. That is, modulation is the process of changing the characteristics of a high frequency carrier with respect to your instantaneous value of message signal. That is called modulation. And if you change your amplitude, frequency or phase of your carrier, it is called amplitude modulation, frequency modulation, and phase modulation respectively. You will always change your properties of carrier with respect to your message signal. And remember, carrier is always high frequency, message is always low frequency. And we also saw different examples or different needs techniques that associates modulation. What is the need for modulation? That also we discussed. So one thing is to radiate your low frequency signal, and reduction in antenna height increases the range of communication, improves the quality of reception, it enables multiplexing, it also reduces noise and interference. So these are all advantages or need for modulation. So why modulation is essential? So these are all points that necessitates the need for modulation. So clear? So that's all for today. Thank you.